Alright, let's look at the homework 4.7, problem number 1. Alright, so we have a 3 by 3 square piece of cardboard, and we're going to cut off squares from each of 4 corners to build an open box, and we want to make it as large as possible. Alright, so let's do that. Alright, first draw the several diagram, and then okay, so we draw a diagram, right? So this is a picture. So we've done that, and then part B, draw a diagram illustrating a general situation. Okay, so this part is finished. Alright, so then write an expression for the volume using both x and y, right? So in this case, y is the right here. Y is the one side of the base, so it's a y by x. So if you want to find the volume, it's going to be xy squared. Right? And part D, use the given information, write an equation that relates x and y. Right? So we know that here, if you look at the picture, right? So in order to find y, so y is right here, right? But the y is simply y is equal to, right? So you're going to have 3 feet to start with. You're subtracting, eliminating x on both sides, so it's going to be 2x. So the equation is going to be y equals 3 minus 2x. Right, we have that. And then use D to write the volume. So we just have to plug this guy back in here. So you have x, and then y is 3 minus 2x, and then you have to square that. Right, got that. And then finish solving the problem. So we have to find the critical number and to make sure that it's the biggest volume. So let's do that. Alright, so the volume function came out to be x times quantity 3 minus 2x squared. So we want to maximize it. Right, and this is over interval. Right, so x is going to be start from 0 because we don't want to do a negative number, and all the way to 3 over 2 because you have to take off x from both sides, and then you have only 3 to begin with, so 3 halves. Right, then let's find the critical number. So you have v prime of x is equal to, right, so we can use the product rule on this one. So this is the first guy, this is the second guy, right? So derivative of the first is 1 times the second, quantity 3 minus 2x squared, plus first x times derivative of the second, so it's a 2. Keep the inside function as it is, to the first power, multiply by derivative of inside, which is negative 2. Right? Then we can just pull out the common factor. So you have a 3 minus 2x. There's two of them here, and you have 1. So we can pull that out. So you have 3 minus 2x. And nothing else is in common, so we're going to have to pick up the leftover term. 1 doesn't do anything. You have 3 minus 2x, so we have a 3 minus 2x. And then we're going to have negative 2, negative 4, x, so there's going to be negative 4x. Alright, so if you clean it up, you're going to get 3 minus 2x, and then you have a 3 minus 6x, right? But the 3 and 6 is multiple of 3, so I'm going to pull out the 3. 3 minus 2x, so pull out 3 from 3, you get 1. Pull out 3 from negative 6x, so you get negative 2x. So if you set that equal to 0, we can find the critical number. Critical number first, if you set this equal to 0, you get 3 halves. If you set this equal to 0, you get 1 half. Right? So But if you notice that it's actually the 3/2 is also the right endpoint. Right, so we have only 3 places to look. So V of right endpoint, which is this guy right here. Right, and then we're going to do a V of critical number, which is 1/2. So we use that one. And also 3/2 is the critical number and also the right endpoint. So we're going to look at that. So 3/2. Right. Right, V of 0, if x is 0, V is going to be 0. So that's easy to do. And also another easy one is V of 3/2. So if you put 3/2 here, 3 minus 2x is 0. So this is going to be 0. Right, and then so only positive number we get is this. So x is equal to 1/2. Right, 3 minus 2 times 1/2 of 3 minus 2, so which is going 3 minus 1, which is 2 squared. So we can see that the 2 on the bottom, one of the 2 cancel out, so your answer is 2. Right, so but this is the largest volume. Alright, so let's type it in. Alright, so largest volume is 2. Alright, let's check the answer. Alright, I came back and looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.